Hello, this is Mr. Pedraza, and today we are going to be talking about projectile motion. And we're going to start with problem-based learning task number 5. It says a rock is catapulted from a tower. The initial speed of the rock is 64 feet per second, and the height of the tower is 80 feet. So you can imagine some kind of tower and a rock catapulted from that tower and eventually hitting the ground. In our quadratic equations, we were told that negative 16 is the force of gravity. So when we're talking about feet and seconds, you'll see that negative 16 there. If we were doing meters per second or yards per minute, it might be a different number, but for feet and seconds, it's negative 16. The number in front of the t is the initial speed. So I'm going to write plus 64t. That number in front of t is always the initial speed. And the last number, the constant, is the initial height. It's the height you would get if you were to plug in 0. Now that front number could be y equals or it could be h equals. Really, it could be any letter. I'm going to go back and change that to h. H for height. Okay, so that is the equation of our rock. If we want to know the height off the ground after 1 second, what I'm going to do here is plug 1 into both t's and make sure that when you substitute numbers, you put them in parentheses. Then you're going to go ahead and type that into your calculator. And I've already done all the calculations and wrote them down in advance. But you could pause, make sure that that's the number you're getting from your calculator, 128 feet. So maybe that is right about here. And I'm going to go ahead and plug in 3 seconds. I'm going to change that 1 to a 3, type that in my calculator, and I also get 128 feet. Now, does that mean that the rock was 128 feet at 1 second, 2 seconds, and 3 seconds? No. 1 is on the way up and 1 is on the way down. So at 3 seconds, it's also at 128 feet. C says, how long does it take for the rock to reach the ground? Well, the height of the ground is 0 feet. So instead of plugging in for t, I'm looking for t, and I'm looking for the t that makes h equal to 0. And whenever I'm solving for t, I either need to factor or do quadratic formula. This particular quadratic equation can be solved with factoring, but most can't. Most you need quadratic formula. And so we're just going to jump right in and do quadratic formula. Now, if you remember quadratic formula, it's negative b, so it's negative 64, plus or minus the square root. And the thing that goes underneath that square root is the discriminant. So I'm going to go over here and do the discriminant. Discriminant is b squared, make sure you put in parentheses, minus 4, if I made a mistake. So that b is 64 minus 4 times a times c. And you go ahead and type that in your calculator, and what you should get is 9,216. And this is all over 2a. A is negative 16, so 2a is negative 32. Now that number, 9,216, happens to be a perfect square, which means it is factorable. And we're going to get 2 rational numbers out of this. So when I go ahead and solve, and now that I'm looking at this, I wrote x equals, it's really t equals. I'm going to get t equals negative 1 or t equals 5. When I do the plus, I got negative 1. When I do the minus, I got 5. Now, negative 1 wouldn't make sense in our problem. 5 will, and that's our answer, 5 seconds. 5 seconds is how long it takes that rock to reach the ground. So going back to our little sketch, 1 second, 3 seconds, 5 seconds, it's on the ground. Projectiles travel in parabolas. And these will always be upside down parabolas. And that front number is going to be negative 16. And remember that negative numbers in front cause the parabola to open down. I have a little sketch here. That uppermost point is the vertex. And the vertex represents the maximum height of the projectile. And if you remember how to find the vertex, you use this little equation, x equals negative b over 2a, when it's in standard form. So when you have a quadratic equation in this form, you do negative b over 2a, that gives you the x of the vertex, and then when you want the y, you simply substitute that number into x to find y, and we'll see some of those just now. Okay, so here's the first example. In this example, we'll look more of what would be on a quiz or a test. It says a ball is thrown in the air and its height is given by, and the equation's given. This number represents the force of gravity. This is the initial speed of the ball. So this ball would start at 48 feet per second. And this is the initial height of the ball. We're throwing a ball. So when it lets go of a person's hands, it is 4 feet off the ground. So A says, what is the vertex of the parabola? Okay, so I'm going to use my equation, x equals negative b over 2a. And so I do the opposite of 48. And 2 times negative 16. I would suggest multiplying those first and then dividing on the calculator, and you end up with 1.5. So it would be 1.5 comma something. Well, how do you go and get that something? Well, that is the second coordinate of your vertex, and so we are going to substitute 1.5 in, and we are putting it into both t's. And you don't have to write this out when you do it. You could just plug those two numbers into your equation, and out will come the height. Now over here I realize I put x again, and it's fine if you write x, but this equation is actually t's. So when I did my negative b over 2a, I got the input of the vertex, the first number, this is the t, and then I plugged it in, I got the second number, the output, which is the h, and I typed it in my calculator, and out comes 40 feet. So I just write 40. Okay, that's the vertex. It says, what does the t coordinate of the vertex represent? That 1.5 is the time. That is when the ball is at its maximum height. The h coordinate, which was 40 feet, is what the maximum height actually is. So the first number is when it's at the maximum height, and the second number is what the maximum height actually is. D asks, what's the height of the ball after 1 second, 2 seconds, 3 seconds, 4 seconds? And all of these, you're just letting t equal these numbers. So t equals 1, t equals 2, t equals 3, and t equals 4. So just like I plugged in my 1.5, I'm going to plug in these numbers. So I'm going to do the first one here and write it out. And the other ones I would just suggest using your calculator. So even though I wrote this out, I would probably just be typing this into my calculator. Plug in 1, see what comes out. And you could do it by hand if you'd like, but sometimes the numbers get a little bit more challenging, like 1.5 would have been. I end up with 36 feet for this one. So I'm going to erase some of this work here and just go ahead and write, when I plugged in t equals 1, I got 36 feet. I know that this number needs to be less than 40 because 40 is the maximum. When I plug in 2 seconds, I get 36 feet again. And that's because 1.5, when it's at the maximum height, is directly in between these two numbers. So one of them is on the way up, then it hits a max of 40, and then one's on the way down. And the ball keeps going down towards the ground. 3 seconds, I get 4 feet, which means that ball is almost on the ground. So that's 1 second, 1.5, 2, and 3. When I plug in 4, my output is negative 60 feet. And you can go ahead and plug all those in your calculator so you can see that. If you get a negative, just write down already hit the ground. Now, I'm not saying that it hits the ground exactly at 4 seconds, because it's not exactly at 4 seconds. It's somewhere between 3 and 4. So if I were to put in 5 seconds, 6 seconds, all of those would give me negative numbers, and I would say the ball hit the ground. If I were to graph this, the starting height was 4. This is when t equals 0. And these numbers that are bigger than 4 are all negatives down here. So these are below the ground. I just ignore those. Okay. So the next question is, when will the ball hit the ground? We want to know exactly when it hits the ground. So we can't say somewhere between 3 and 4. We need to figure out exactly when that is. And that involves quadratic formula. So I put 0 into my equation, and it's negative 16t squared plus 48t plus 4. Whenever I'm asking when does the ball hit the ground, I know I put 0 in for h, and I know I'm solving for t, and I know I'm going to use quadratic formula. So if you need to remember how to do quadratic formula, you might need to look back at those notes. It's opposite of b plus or minus the square root. The discriminant goes in here. So I wouldn't write out the discriminant. I would just go right in my calculator and do the discriminant. It comes out to 2,560. This bottom number is 2a, which is 2 times negative 16. And then I would type that in my calculator the way we learned. For the first number, I get negative 0.08. I just cross that out. Can't have a negative time. And I get 3.08 seconds. And that's my answer. And if you go back and look at our graph, we know that that ball is hitting the ground right after 3 seconds. And that's why I ended up with 3.08. That negative number I'm getting is if I were to go backwards in time. And of course, we don't go backwards in time, but you could see if the ball was moving this direction, which it isn't, I would end up with another point on the ground. So you just ignore that point because, again, it doesn't make sense. Okay. If you feel like you understand the notes, you do not have to watch this last problem. Example 2 is just like example 1. It's just a different example, this time with a cannonball, and it has a very fast initial height. So this is going to go much further than the ball was. So let's just jump right into it. It says, when is the cannonball at the maximum height? The key word is when. We want to know what time, so I'm going to go ahead and do my vertex formula and find t. Negative b over 2a. Out of that comes 12.5, And so 12.5 seconds is when the cannonball is at a maximum height. If I want to know the actual maximum height, I take that answer that I just got and plug it in for t. So that is going in for t. I would type all that in my calculator. I would not try to do this by hand. Make sure you put these in parentheses. Make sure you type in the squared. And check yourself to make sure you're getting this answer. 2,502 feet, which is not unrealistic for a cannon. A cannon can shoot over a mile in the air, and this is about half a mile, which is, again, very far, but not unrealistic. Okay, for these questions, I'm plugging in t equals 1, t equals 5, t equals 12, and t equals 20. And you're more than welcome to pause and plug these numbers in yourself to make sure you're getting these answers. You don't need to write out the work here. You're just taking 1 and plugging it in, just like we did the 12.5. 1 second was 386 feet. All these answers should be less than 2,502. 5 seconds is 1,602 feet. That's on the way up. 12 gives us 2,498 feet. And that makes sense because our maximum height is at 12.5 seconds. So 12 seconds is half a second sooner. So at half a second sooner, it's close to the maximum height. 20 gives us 1,602 feet. And that 20 represents the cannonball on the way down. Then we want to know, when will the cannonball hit the ground? So I am plugging in 0 for the height. And on these when will it hit the ground problem, you are always doing quadratic formula. So my quadratic formula would be x equals negative b plus or minus the square root, and this is going to be b squared minus 4ac underneath the radical, all over 2 times a. This one I think I'll write out for you, just in case people started getting lost. This is what the quadratic formula looks like when you write it out completely. Underneath the square root is the b squared minus 4ac. We've been skipping to this stage and just typing in the discriminant into our calculators. And that discriminant is a very large number, 160,128. Okay, then you're gonna do this in your calculator. The first number comes out as negative. Get rid of that. The second one comes out to be positive. It will not always be that the first one is positive and the second one is, or first one is negative and the second one is positive. That happens a lot. But it won't always be like that. So you should do both. If you start with a ball that is on the ground, you will get 0 and then a positive, and then you throw out 0. For instance, if you hit a golf ball off the ground, it would start at 0 and end at 0 feet. And so 0 seconds, that's not what you want. You want the time that is in the future. And so if you get a 0 and a positive, throw out the 0. If you get a negative and a positive, throw out the negative. The positive answer is the one you want. The answer to this last question, if I can write neatly, is 25.005 seconds. I rounded the 3 decimal places because the 2 decimal places, this actually rounds to 25.00. So I do not want to write 25 seconds. That may look like a guess. So that's it for the notes. Make sure you go ahead and try the homework.